Hey there, I'm Joseph, your Web3 dev, and in this video I will show you how you can use the Peanut protocol to send crypto with a link. It has never been easier to send with a link, and I think this is a genius idea. So let me show you the app that I've built. First, let's connect our wallet. So we pop up MetaMask right here and connecting our wallet. And as you can see right now, I'm on the Goerli network, but it works even on mainnet or on Sepholia, for example. So I have 2.1 goerli ETH. And we can, for example, let's say we want to create a link that gives away 0.5 goerli ETH. So we can create this. And when we click the create link, we pop up MetaMask to confirm that this is a legit transaction. And this might take a moment. So what we're doing right here is we're creating a new claim link right here. So this has 243, and when this transaction goes through, we will update, or this link will be updated, and we can then share it with a friend of ours so they can claim this 0.5 goerli ETH. There we have it. It took a moment, but that's the new link. So we can either copy this and open it in a new tab, and there we have it. We can either connect our MetaMask wallet to claim this 0.5 goerli ETH, or we can enter our wallet address manually right here. But now there's another way. So this is good if you want to send it to someone else. For this example, we are doing this for testing purposes. So I'm just going to claim it from here, which means that this 0.5 goerli ETH will come back to my original wallet, which is the one I'm connected to right now. But first, let's check the status. If this is claimed already, no, it's false. That's perfect. So we can claim it. So we click claim link, and then we need to confirm this transaction. And in just a couple of moments, we will see the transaction hash right here. And that means that the transaction is completed. So there we have it. It took a couple of seconds, but we can click this and go to Etherscan on the Goerli network. And we can see that the transaction actually happened. Now that's pretty cool. We can go back to MetaMask and see that it went down to 1.6 and now back to 2.1, which is 0.5 more than 1.6. So that means it works. That's perfect. Now let me show you how you can build this dApp in a few but simple steps. So let's open the project in Visual Studio Code. I've named mine Send with Peanut, and let's open the page.js file right here. So first I import the image, this one right here, so we can display it. And then I also import the header component and the Peanut component that I will show you very soon how to create. Now there's another component here as well, the connect wallet. This one is rendered within the Peanut. But let's start with the header.js file, which is the header itself. So we only display the image right here. And then we have the connect wallet, which checks if the wallet is connected or not. As you saw in the beginning, I displayed the connect wallet button because I wasn't connected, but I don't want to display the button. I want to display this if a wallet is connected. So that's what we're doing right here. Immediately on use effect, we run this check if wallet is connected function, which is the one down here. So we do window.ethereum.request and we store the response in accounts. So we check accounts.length. If that is not equal to 0, that means that we have a wallet connected. And then we can store that inside the set current account, which is this state variable right here that we created. It's an empty string to begin with. And then when we render, we can see if this is true. So if we have something, or actually if we don't have anything, we want to display the connect button. But if we have something within the current account, then we're not gonna display anything. But if we display the button, we have this onClick function to connect wallet, which will run this code here. So you can be able to pop up MetaMask and connect your wallet. And then we store this account.0 inside the current account. That means that this won't be shown anymore. And this is rendered within the Peanut component. So let's go on into this one where it's happening a little bit more, but let me show you that here is where we render it, the connect wallet button. So let's start from the top. We import use effect and use state. We import link because we want to create a link with this transaction hash. And then we import ethers and also Peanut from Squirrel Labs /Peanut SDK. And then also the connect wallet component that we just went through. So we have a few state variables. We have the current account, so we can check if someone is connected or not. We have the signer and the set signer function, and it's set to null to begin with. We have the amount and set amount. we have the link, and this is the original link that we are showing. We can actually have this to an empty string. That works perfectly fine because we're gonna populate this with a correct and updated link once we create a new link right here. Then we have the link status and also the claim transaction. And immediately, the same as the connect wallet component, we check if a wallet is connected, and we're doing it right here. And if we are connected, we have this variable, the provider. So we want to take this code and use this when we create a signer. So we use provider.getSigner, and this will be used later on when we actually want to sign the transaction. And then we also have the account equals to account, and then the first index within that array. So we set these two values right here. And if we aren't connected, then we just console log that no authorized account has been found. So we have a few more functions. We have the create link function, the claim link function, and the check link function, check link status function, which are pretty straightforward. Just by the naming, you can understand what they are, but let's go through them one by one once we check when we render them. So we look for if the current account is true or not. So if it isn't, we display the connect wallet component, but if it is, we display all the other things. So one of the things we have here is the input field for typing the amount you want to send to a friend. And then, so we run this set amount setter function for the state variable amount to change to the correct value. And then once you click the create link button, we run this create link function. So what does that do? First, it takes the network and the chain ID, so it knows on which network you're acting on. We did it on goerli, but you can do it on sepholia or on mainnet as well. And then we create the link right here. So we're using peanut.createLink function, and we're passing along these 5 parameters. So we pass along the signer, the chain ID, the token amount, the token type, and then verbose, we set it to true. And the token type, we set it to 0, that stands for Ether, but you can use 1 for ERC20, 2 for ERC721, or 3 for ERC1155. So Peanut supports all of these token types, which is very nice actually. So you can play around and instead of Ether or ERC20, you can use ERC721 instead. And once we get the response back, we set link to the new link that we're getting back. So if we scroll down, we have this claim link next, which is a button. And when you click that button, we run this claim link function. So what that does is it checks if signer or link has an issue, then it doesn't do anything. But if it doesn't, then it runs peanut.claimLink and passes along the signer and the link, and it gets back the claim transaction, which we then can extract the hash from it and create that link that we are doing to Etherscan. So we set the response to, or we take the response and we set claim transactions to that response. So below the button, we can actually see if claim transaction is true, and that's when we create this link right here. We're adding goerli.etherscan.io/tx/ the dynamic transaction hash for that specific claim. And lastly, we have the link right here. This is on the right side. So we just display the link as it is if we have one. And then we also have the button, the check link status. So we run this check link status function. So again, if signer or link is not true, we throw an error. Otherwise, we run the peanut.getLink status, and we're passing along signer and link to it, and we're getting back this claimed response. And with that, we can see the status of this link. And that's what we're doing down here. When we click that button, we display the status for the link. So if it's true or false, we just make it to string so we can display it like so. And this was claimed. So if I check status now, it should say true because we actually claimed it. And there you have it, guys. It's not harder than this. Let's reload the page and let's do 0.2, for example. We create a new link, so that means we pop up MetaMask, so we confirm this message, and we have 243 here. So let's wait a few moments until this updates correctly. There we have the new one. So let's copy this and check the status first. So it should be false. Let's paste this in. 0.2. Let's do it this way this time. So we have 1.9 here. I'm gonna copy this, put it in there manually. Now it's processing. And there we have it. It took a few moments, but we finished this and we can see the transaction hash here as well. And if we open MetaMask, we can see that this is back to 2.1. And if we go back to our application to check the status, it goes from false to true. There you have it, guys. Very quickly, very easy. I think this is super cool to use the Peanut protocol to send crypto with a link. That's very easy. And I hope you enjoyed this quick video. If you did, make sure you smash the like button, subscribe to the channel, and I will see you in the next video.